Hi, everybody. My name is Waylon Lee, and I am part of the Space Team's core software development team. Today, we'll be talking about just the Space Team's professional applications and what we have in store, a little bit more technical. So first off, we'll go over some of the code design that we have here. We have an advanced code design within Space Teams and a fully asynchronous architecture. So the ability for us to multi-thread all the actions that are happening within our simulator. So this really is powerful because it allows for us to have independent timing requirements for every part of the sim, such as dynamics running at 5,000 hertz, telemetry from a vehicle coming in at 30 hertz. And so really that's just the deep end of the code design. We have a very robust code design with that, so you're able to do network replicated generic data structures for all of these sim states. It's super useful for really all simulators out there. Of course, this is also modular, so you can port all these behaviors of the simulation between each other. So say you want to change something happening on your dynamics, it's interchangeable, very easily modifiable. We use C++ 17 for our core libraries, and this is cross-platform. So this is Windows, Linux, Mac OS supported at the time making of this video. So one of the things I want to point out that is a feature within our Space Teams Pro is that you have the ability to do asset editing and sharing. So the Professional Edition comes with game engine-like tools for editing assets, such as assets and like in Unreal Engine 4 or Unreal Engine 5. So you can edit kind of these things called assemblies of parts. Assemblies are essentially a conglomeration of those CAD models that you put together. You can make new parts by importing it into your own files and downloading others and having a shared asset assembly. You can edit simulations, so you're able to do that within this thing called SimConfig, which is essentially a JSON file for the users to mess around with and create their own sims. We have the ability for us to mess around with these sims inside of 3D and virtual reality, and you have a lot of good sim configuration tools and helpers for you. It's cloud-based asset storage and management, so when you're updating and importing your assets directly into Space Teams, you're able to do that as well. And of course, you also have the ability for using Git or existing sources of source control, anything to your choosing or liking. So some of the user accessible APIs that we have within Space Teams Pro, we have C++, Python, and we're working on Lua, MATLAB, and Simulink, as well as ROS, and Asatric, and more. Within Space Teams Pro, you have the ability to work in human-in-the-loop operations. We feel as though this is good to point out because you can have multiple people inside of a simulation, inside of VR, running a surface operations or an Artemis lunar VR training, as you can see inside these screenshots to the right. You can have your avatar inside of there, so you can look around and have your own spacesuit inside of these simulations. We have the ability to use full body inverse kinematics. You can have procedures displays, robotic vehicle teleoperation, failure modes within those, and we have a whole suite of custom VR control interfaces available to the users of Space Teams Pro. Post or before a simulation, you can run a Monte Carlo or do analysis and optimization on all the parameters. Within each simulation, as I said earlier, you're working inside of a simulation configuration file or a SimConfig. You can actually scatter those parameters in a Monte Carlo way and run store, stop, freeze, and run a bunch of these simulation runs and pull the data out for analyzing. Inside of Space Teams, we've built in those analysis tools, so you have the ability to do multidimensional graphing like matplotlib, live graphing and parameter tracking of each value. You have an easy way to create your output configuration in CSV files or other ASCII type files, as well as to optimize across a sim with any of those user-generated parameters. So I'd like to go quickly over the comparison with some similar software that's out there at the moment. I won't go through each of these pieces, each of these other softwares, but I'll go over some of the highlights. And you can pause the video whenever you like to take a look at each of these slides. So Space Teams is on the left, and of course we're going to be comparing to FreeFlyer, STK, Trick, Doug, Blenda, Cesium, Roblox, Omniverse, KSP, VBS, DCS, and Microsoft Flight Simulator. So just a thing that Space Teams has from the scope of a rendering, from the rendering side, we have really the entire solar system from any perspective. We're able to get that very high resolution surface data, so we're able to get all the way down to 1 centimeter precision. We can interact with all this inside of virtual reality, which not all other simulators have the ability to do so right out the box. You can really easily model import your CAD without having to edit the software itself. We utilize real-time ray tracing for our rendering features, as well as 64-bit double precision, which is important for your dynamics or going very far out from, say, planet to planet or solar system to solar system. Within simulation, we have sim features such as orbital propagators, planet ephemeris, very easy sim setup and editing with a sim config file. You can have the ability to use multi-user, full language support for C++ and Python, frame transformations, assemblies, resource flow. So say you have oxygen in one module of your spacecraft, and you want to see how it'll interact if you add it into a bigger space station, how those resources of oxygen flow through. We have a nodal network server for that. Space Teams also features all of these right here: automation, Monte Carlo, virtual displays, just a whole library of 3D models for you to use from, sensor modeling and actuator modeling like your thrusters, as well as all the VR interactables and environmental modeling. So I'd like to talk a little bit more about that environmental modeling. But inside of our environmental models, we have very deep things such as a full harmonic gravity. So it's up to 360 by 360 spherical harmonic gravity models. We have a variable degree and order per gravitated model. We have Moon, Mars, Earth, which is very high fidelity. We have zonal gravity models for Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune. We also utilize SPICE's ephemeris data. So for the positioning of our planets within our solar system sim, you're able to use that. Whenever you load into a simulation for the first time, you're typically going to be loading into our Solar System Explorer sim, and that sim utilizes the correct time right now whenever you open it up, and it'll put the planets where they should be, the sun where it should be, to create accurate lighting conditions for you. We have this thing called the rigid body propagator. We just work off of that. And it uses our K4 Newtonian dynamics as well as Eulerian attitude dynamics. And then the GMRAD data, the planet surface data, I talked a little bit about it earlier. We had the ability to really have high fidelity data inside of our terrain. That model or that system is called the GMRAD planet surface geometry system. And we also have the ability to have solar radiation models. We have that already built in with Space Teams. So it includes the radiation pressure for the sun, the area of the spacecraft exposed to the sun, as well as black body calculations for you. And we have atmospheric wind available to you from within Space Teams. So that was a little bit more on that that really high fidelity environmental modeling, but we'll talk a little bit more about the collaboration features. So some of the collaboration features within Space Teams versus all these similar softwares, we have really nice source control. We have multi-user assembly editing, so you can have multiple people working on the same project at the same time within the same sim, save that off and run it off. So say you're building a spacecraft in front of each other, you can do that. And we have the ability to we are cross-platform, so we have Windows, Linux, Mac OS, ARM64 capabilities, and we have VR headset supports using Steam VR. Well, that's all I had for today. Thank you so much for your time. Have a great day.